Hi, Shunyun.
Hi,
Sorry,
hi. Yeah, sorry. I think
I wasn't messing.
yeah. Please let Herman know that he should be coming online. There was a mistake in someone who thought the event. There's another event, 3 p.m. at the same room.
Oh, okay. So should I
Okay.
just ask him to join
Yes,
us?
yes,
Oh,
yes,
there.
yes. Exactly. Oh,
Let's join.
okay. Herman. Hi, Herman.
Join
How are
us.
you?
Hello, sir.
Hello, Herman. Can you hear us? Hello,
Hello.
Herman.
Hello,
Hi.
There.
hello.
Yeah, apologies. That person should be here by an hour later. Okay.
Oh,
All right.
okay.
All right. So yeah. So let's start. So how have
Happens
you
to the
guys
best of
been
us.
this weekend?
Yeah, we've
Good.
been all right.
Okay,
Been
great.
okay.
Great.
All right. Um. Okay, I'm just gonna share my screen.
Okay. Sure. 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 Yeah.
Uh. Screen one. Yes. All right.
So we're looking forward to
So,
the new algorithm. Okay. So go ahead.
can you see this?
Yes. Yes. Yes.
So I will be sort of switching back and forth because I'm trying to sort of put as much as possible together in a small piece. But anyways, so I remember you said something, I think on Friday, about maybe going back to assumptions, what my assumptions were with regards to
Right.
pop sub. And I was like, you know what? I actually started with this diagram here and it made sense in my head, but I felt like I was complicating my life. So I basically went back one by one until I went back to the very core, which is simple. So I just assumed we have a region. This is a simple region, a pop sub region, or some let's not pop sub, um, a spatial region. No Voronoi overlay, no vast library. It's just you have nodes, maybe lots of subscribers and one publisher, right? So this is the publisher. I am, from what I understand, you have a publisher. It has a publish sort of channel, or it creates a sort of it creates a couple of channels, which in this case I call them 00 channel, 01 channel, and 02 channel. And then you have all these nodes that basically subscribe to their channels of choice. Uh, am I on the right track?
That's the channel-based pops up. That's correct. For
Channel
channel-based
based
pops up.
pops up.
Yes.
Yeah, perfect. Okay. So I sort of took it up a notch, not necessarily up a notch, using okay, so I created the region again, and this time in what's the word now, sort of Voronoi layer, but sort of trying to apply the same principles from that, from channel based pops up, right? And I think we sort of have this. So initially, if you look at this, I called it pub region. The reason why is if you look at these diagrams, I created like four different regions where I was saying C has its published region, which is the square area. I has this area. E and S basically have this publishing regions, and the idea was to now say, okay, for each region, sort of create a sort of definition for it. But I was like, you know what? Let me keep it simple for now. And so we can actually call this region a piece. Um, we can call that maybe one section of this whole bigger what's the word, bigger picture, right? So we have that each publisher has a pub region. So for this region, it's sort of the simple the similar process where create the array, find, create the network that's basically starting up the gateway and everything. Send so this is subscriber now. You have a node that wants to subscribe to E, sorry. uh, you know um it's simple, find, not necessarily find, but the idea is each node is sort of predefined with the it has not necessarily has an idea of what's going on around, but it knows the nearest server, right? Or this the assumption that it knows E. It knows about E. It knows about the region it's in. It knows about what's broadcasting or what's publishing messages to each channel. So the idea is, um, send a signal to the server to subscribe, and if it's successful, simple, success message or something, and if unsuccessful, failure message. Thing with the the publish mode. Not same thing, sorry, but the idea is sort of simple. When you power on, you want to create the identity, the whole identity, or the position, the address, and the subscription list, right? And I think I noticed, if you noticed here, I sort of added this, but this is subject to change. But again, this pub reg is sort of the information that both the publisher and the subscriber shares, right? So the subscriber the subscriber node already has its predefined, what's the word, uh, information that, okay, this is the region I'm in now, and this is I have these channels I want to subscribe to. So I wonder if this publisher has the information I'm looking for. So yes, create data tables for subscriber basically structures the data, wait for connection requests. If the requests, so if the publisher gets a request, this is a publisher now, not subscribing. That was a mistake. Get the identity from CH sub, so that's the channel subscription list. Compare with the subscribers list, and if it has what it's looking for, then just subscribe to the channel, or subscribe to the message. What's the word? Yeah, message topic or channel that that it's relevant to. And if it doesn't get the message, say give an error message or something. Now, when I go back to this now, again, this is under if this is under the channel subscription mode. Now, I'm not. This is not. This is a. I'm picturing a scenario where you have a farm, for example, or let me not even say a farm. You have a sort of, yeah, let's say a farm, and maybe the channel for a certain region is temperature. Maybe a certain room, the temperature of that room is important, and it needs to sort of be measured constantly by multiple sensors. So the idea is, you want to subscribe to the temperature channel, uh, to every data, all data that comes from the temperature channel. And it sort of gets more complex now when you now uh, add, what's this thing called now, the sub region. Now, I do have a question about this. I think I sort of confused myself here. How pub region and sub region sort of intertwine in a spatial, what's the word, in a spatial scenario or case study. Now, um one question: can I tile can I use tiles to illustrate Voronoi, Voronoi space?
Sure.
Sure, okay.
Because try to get the basic concepts across.
Yes.
That's the important
Okay.
thing first.
Because in where I am, we sort of have tiles, and I was sort of trying to picture the movement. Say I have D, so I'm just gonna try to say it as I wrote this in my book. So in a decentralized spatial context, now this is with Voronoi, or at least what I picture. Um, we have D. Let's say not this is not a special node or anything. It's just, let's say we have F that wants information or to a certain channel that only D provides. Right. So the idea first is, okay, check the neighbors first, send a message to the neighbors around to see if if C, K, or L have the information they request, it requires, right? So this is the assumption that only D has this information. So what do? You check, and if you see that it doesn't have the message, the idea is forward the message, right? Or forward the request, sorry, to the forward the request. So in this case, L makes the request to OMK, right? If it doesn't find it, the same thing. So if you once we do this, you start not. One thing I added was to now store the path, in which each node stores the path in which the forwarding request is. It's sort of moving, if that makes sense. I don't know if, but when I, for example, if I make a request to C and it doesn't, and before C forwards the message, it wants to store the path CF, and then when it gets to A wants to store the path ACF, right? Until the forwarding message gets to D. Now, when it gets to D, I think we would get basically two parts or two real parts, H and N, like from the stored, when by the time the stored parts are on each node, you get two major parts. So the idea is, once the sub request is received, then send the what's the word, the subscription messages through that path, the shortest path. uh, I don't know if that makes sense. I think I might be taking it a bit too far, but it was something I sort of came up with on the spot. But the idea is, by the time the request gets to D, it already knows the path the message is coming from, F, right? So each path is stored until it gets there, and then the idea is D figures out the fastest, based on the stored parts. It's gonna sort of measure the distance and say, okay, the shortest path was maybe ND NBMNOL or something like that, if that makes sense. Mm. Um, but yeah, that's, I
Okay.
think,
Yes. Yes. Makes sense. Yep.
if that's
So you're
what.
thinking about that when the time D, which is the final destination, receives,
Yes,
it also knows how can it reply back.
yeah,
Is that what you're
exactly.
saying? Okay, I see.
Yes.
Okay, all right.
So the question now from my side is, in a spatial, what's the word, spatial pops up, especially when, or I think maybe I don't know, I've been thinking about it. Does it need to be specified, the Voronoi spatial pops up? um
No,
I-
no, no, it's not
because
necessary.
it's
I mean,
unnecessary. Okay.
Voronoi is a way to partition the space, but there are many other
Exactly.
ways. Okay, you can
Exactly.
do a regular partitioning like what you have here by grids, by hexagons, by triangles. People have used all sorts of shapes to do the partitioning. And also
Okay.
you can use something like a quad tree. Okay, a quad tree, if you know that, that's by division into 4 quadrants, and then each one can further divide into quadrants. So it kind of builds a tree. Okay, so
Yeah.
there's also that kind of approach. Yeah.
Okay. So
Um,
I did want
okay.
to ask, sorry, if,
Go ahead.
um, so now we have the Von partitioning,
Right.
right? And I'm still, I don't know if that's the right way to put it, because I feel it seems like there are sort of two different things,
Mm-hmm.
or should I say, the Von partitioning feels like a more specific way
Mm-hmm.
to address spatial routing, or should I say spatial pops up, if that
Mm-hmm.
makes sense. And if, you know, let me try to go to the picture. If these partitions already exist,
Mm-hmm.
or if, for example, let's say this is a spatial region,
Right.
right, and all of this is maybe defined by a network,
Mm-hmm.
or this region, all of these nodes are, you know, so how does Von sort of fit into this,
Okay.
right,
Okay. All right.
in a centralized, in a centralized mode, or
Okay.
setup.
Okay.
Sorry.
Well, if you're talking about centralized setup, then actually, I don't think you have to have a VON for that.
Okay.
Okay, right? Does that make sense? I mean, a
Yes,
VON
because
is
I
needed
think
only
those.
when you want to coordinate a number of nodes. Okay, for
Okay.
the purpose of managing space. Okay,
Mm,
so basically, this necessarily means that it's a decentralized approach.
okay.
Okay, that makes sense.
Okay. Yeah.
Okay, if it's not if it's centralized, then it's very easy. You just have a client server architecture.
Thanks.
Okay,
So
right?
I think I was confusing myself because I kept trying to fit fast
Mm-hmm.
into this centralized approach, but it didn't seem necessary.
No, no, no. It's not. I mean, if you have like a fully centralized, setup, then there's no need or no space for running, VAST. Although, if you are talking about in a cloud environment, okay, where you have cloud servers, okay, then you could still have you could still use VAST or something like VAM to
Yeah.
do the space partitioning. But essentially, you are managing a number of super peers, you know,
Yeah.
by using the cloud resources.
Okay.
That does that make sense?
Yeah. Yeah.
Yeah,
So
but essentially, you are building a peer-to-peer network within some kind of server, cloud-based environment.
so basically in a sorry centralized setup, or should I say in a Vaughan centralized setup, this
Mm-hmm.
is basically what will sort of happen where those lines or those frames sort of at the partitioning. It's
Right,
like
right.
some but
I mean, if you only have a centralized, then that means you have like one server or one entity that is managing all the subscription lists and also the
yeah,
doing performs the pops up matching.
yeah,
Okay.
yeah,
Yeah.
exactly.
All right.
Okay.
So, Herman, so is that what you have so far?
Sorry. Yes,
Mhm.
yes.
So okay, so
Okay.
yeah, I think uh, uh, I don't think you should try and fit Von into the spatial publish subscribe layer at this stage. Okay, in terms
Okay.
of I think you should think about Von as a way of it's just some way for your nodes in a decentralized manner to know who their neighbors are. It doesn't matter um, how they know who their neighbors are, but it's just a way of getting a list of neighbors and basically also you can think about it. You're gonna give the Von layer a location and you're going to ask which node is which of my neighbors are closest to this location. That's, I think, from a spatial PubSub point of view, that's basically all you want from the Von layer, right?
Mm,
Um,
yeah.
so I think the yeah. So I think your what I would suggest you do is you would take the four actions of spatial publish subscribe. In other words, subscribing to an area, publishing a message, perhaps moving a subscription area. I think is there a fourth one? Maybe leaving or unsubscribing. That's probably the fourth one. Yeah,
Mhm.
and
Okay.
basically for basically say okay, but forget about the Voronoi partitioning. If you just have nodes in this rectangle that you have, and they have locations, and you
Mm,
basically want to say, I let's draw a circle. Let's call that the subscription area, and let's assume one of these nodes are a server that keeps a subscription list. What is the what is the sequence of actions that needs to happen in order for a node to subscribe to an area, or to publish a message, or to unsubscribe from an area, or something like that.
Right.
Okay.
The main actions are you can subscribe, you can publish, you can move a subscription. Okay. And obviously,
Yeah.
yes, you can unsubscribe.
Subscribe.
Okay.
Move and
Yeah.
subscribe. Okay.
Right. Right.
So
All right. So Herman, you have any other feedback?
Sorry. Yeah. So I think you should. I don't think you should worry about powering on and in terms of initializing a node. I think you must just write down kind of what is the variables, or what is the what's the variables that is, for instance, if you want to look at the server client type of spatial PubSub, what is the data that the server needs to store? And that's basically just a subscription list, which is a subscription area and a list of IDs, of subscription IDs. And then you must define what the data is that's in each message. So for instance, a subscribe message, you want to know the ID of the node sending the message. You want to know its location, and you want to know the subscription area. In other words, what's the area to where you want to subscribe? You might even not need to know the node location, but let's keep it in there. And the subscription area basically is both the location of the subscription area as well as maybe the radius of the circle or something like that. Because then you can think about it like you can write down a sequence of steps, which, like, for instance, let's say when you subscribe, you would start by node A sending a subscription message to the server, and then that subscription message contains the node ID, the node location, and the subscription area. Then the second step perhaps is that the server sends a confirmation message back to the node. The third step would be that the server adds the subscriber and its subscription area to its subscription list. And that's basically, after those three steps are done, the system is, has subscribed a node to a subscription area, and then that part is done. So you can think about that as an atomic, or a atomic action, or maybe atomic is the wrong word, but basically once these steps are finished, the whole subscription action is done. And then you can say, okay, so now let's assume that the server has a subscription list, and subscribers have already subscribed to areas or whatever. Now someone wants to publish. Okay, what are these steps? First, send a message, then perhaps send a confirmation message. Then what does the server need to do? How is the message then sent to each of the nodes that needs to receive it? So I think if you can write down those steps, that's basically what we're looking for in terms of the algorithm design.
Okay. It actually sounds, again, like, it sounds so simple.
Yes, it is simple.
But I really think maybe the Voronoi, I sort of was overthinking the Voronoi part, or the Voronoi layer. But okay, it's fine. Let me try to come up with something. Can I ask again? Sorry, I know it's not very convenient. If you're available tomorrow morning as well.
Tomorrow morning is going to be, let me just see, but I actually think tomorrow morning is going to be tricky for me. I have a meeting with my dean tomorrow morning, but I might be able to fit in. I could perhaps do over lunch from 1 to 2.
Okay.
Yes. Cool. So maybe I should ask, so why do you want to fit the Voronoi into the spatial PubSub at this stage?
No, I actually didn't. The thing is that maybe that was my mistake, I think, because I kept putting the Voronoi layer, and because of that, I kept conflicting, because every time I say, okay, connect to E, there was always that sense of I don't know about E because of the partitioning that, for example, in this case, there was, for example, if I said okay, B connects to E, for example, the Voronoi layer sort of disturbed that a little bit in my head now, not necessarily in practice, because I was like, okay, but I don't know where E is. I only know about A and F. So how do I overcome that? So there was this sort of constant struggle to
So
reconcile the vast layer.
So, okay, I think the basic assumption in a server client architecture is that any node can make a connection to any other node and send a message directly. Okay.
Exactly. And that's, I think this picture here is actually more accurate than all these other ones.
That's the server client. When you have
Exactly.
something like when you have a Voronoi diagram, or when you have some kind of a partitioning of your space, in a decentralized setup, I think the assumption that you should make is that you can only communicate with your neighbors. Okay. Now, how neighbors are defined. So with Voronoi, what happens is you draw a Voronoi diagram, and that basically determines what the node's neighbors are. But for instance, if you do something like a quadtree, there would be a different way of determining
Right.
who your neighbors are. But I think the core assumption is the underlying layer somehow tells you these are your neighbors, and these are the only nodes that you're aware of, and they're also the only nodes to whom you can send a message. And
Okay.
If that makes sense.
Yes, it absolutely does. So it goes back to the global view and the local view.
Yes.
Comparison with decentralized or centralized. Okay.
So all right. So Victor, just
it
some
is clearer.
Yeah. Just
Yes.
some quick feedback. Okay.
Yeah.
Regarding when I listened to your explanation, I see that you seem to allow subscribers to try to find the publishers. Is that right? Because
Yes.
right. Okay. That is something you don't generally do. Okay. Then I'll explain why. The
Okay.
reason is that, okay, okay, if you are trying to find maybe like a matcher, okay, or maybe like a, like a super peer who manages the subscription lists, then it's fine, okay. However, that is just for, to allow the relevant matchers, for example, to know about who are the subscribers and where they are and what is the subscribe area. But you never try to find a publisher. The reason being, any node can publish at any time. You see?
Okay.
You see?
Okay.
That is a one fundamental idea. You have to go back. This goes back to the original pub/sub paradigm. Remember, publishers do not know who subscribers are. Likewise, subscribers do not know the publishers are. Only the matchers do.
Yeah.
Okay? Is that all right?
Yeah.
Okay.
Yeah.
So whenever, even if you are doing that kind of a forwarding, okay, trying to look for, you are not really looking for publishers. You cannot assume that node will be publishing, okay?
All right.
Because otherwise, in your design, you will have to allow a message, something like a publication request, you see?
Okay.
And then propagate that request sort of to the relevant parties. Actually, this can be done in either way, you can send out publication requests and then subscribers just sort of just subscribe. Okay, but I think, generally what's logically more making sense is the subscribers would let the world know about their subscription interests. And whenever there's a node that publishes, okay, the matcher will try to find who the subscribers are and forward it to them. You see? Does that make sense?
Yes, it does.
Okay.
So just to confirm, then it means in a pub/sub setup, a lot of some of these initial, should I say, matches, for example, are sort of predefined on each node.
Well, you can assume that. But I mean, in a dynamic settings, matchers potentially can be, they can come and go as needed. That relates to load balancing. But for now, in a simplified model, you can assume that you have designated nodes as the matchers, or as the pub/sub matchers.
Okay.
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 So
Yeah.
that is one feedback. Okay. The other feedback is this. When you are trying to forward, okay, as in your case, trying to forward to a node, the subscription request,
Yeah.
you don't need to track like who are the nodes on the path in order to go back. The reason being, okay, when let's say a node like the top left corner, right? If that's the final
Yeah.
destination, for example, if you are subscribing an area that is that large, right, to
Yeah.
that node, then what happens is after it match, assuming it's a matcher, okay, and there's a publication that matches the subscribe area, and it needs to send back to your original node, right? Like F
Yeah.
lower right, for example. You can again do a greedy forwarding towards that direction.
Oh,
You see?
okay.
So by that I mean that you don't have to keep track of who are the nodes that is in the path, and you don't also. It also, I mean, not. It's also not necessary or not making sense to track that, because in the case of dynamically moving nodes, okay, assuming that the nodes can move dynamically, the path you
Yeah.
track could become irrelevant.
Yeah.
Does
True.
that make sense?
True. Yeah. Yeah.
Okay. In the sense that what you want is perhaps the shortest path. But if let's say the nodes are, like moving, the matchers, for example, if they change, and which can happen, or if there's a node failure, right? That's another case. So
Yeah.
what happens is you always want to rely on greedy routing, greedy forwarding, to find, whoever you like, the final destination you like to reach.
Okay.
You see?
Um.
Because given a coordinate, you can just use greedy forward to reach that node.
Okay. I think I might have to read up on that. I know I've read up on it, but I think I assume that the greedy forwarding would also need some sort of path to.
No. Greedy forward actually works very locally. It's just that every
Okay.
node, you just pick the next node to forward to, and that's it. The next
Oh,
node that
okay.
is
Okay.
closer, that is closest
Oh,
to
I
the
see what you mean.
destination.
I see
You
what
see?
you mean. Yes.
Okay.
Yeah.
And that is also actually a more effective way to do forwarding.
That's more efficient, actually. Like
Yes,
much
exactly.
quicker.
Okay. And you don't have to keep
Okay.
any records. So just some feedback. Okay.
Okay. Okay.
All
Okay.
right.
I see.
So I hope this helps to simplify your design. Okay. Because those are some of the things I saw. All
Okay.
right. So I think next step would be try to maybe clarify, your procedures
Mm.
algorithm according to today's feedback, and maybe we'd like to see, I guess, a simplified procedure.
Okay.
Yeah.
Okay.
Fine. Yeah.
Yeah.
Yeah, I will do that.
All right.
All right.
Okay.
Thank you very
So,
much.
all right. Okay.
Um.
So is that okay for Herman as well?
Yes, that's good.
So, tomorrow at lunch, sir?
Yes, I'll send
Yeah.
you an invite to the Zoom meeting.
All right.
I
Thank you
mean,
very
well, we
much,
can
sir.
use the, yeah, I'll send you an invite to the Zoom meeting. Thanks. Bye.
Okay.
Okay.
All right. Thanks. All right. So talk on Thursday then. Yeah. Okay.
All right.
Okay.
Bye bye.
Thanks, Junior.
Bye.
Yeah. No problem. Bye bye.